So the first thing I just want to make clear here, like for question 5, people we're sort of struggling on how you use a compounded growth or growth over time, how you adjust things mathematically, right? So the first point to note is if you don't know how to do this, it's not because you don't know your economics, it's because you don't know your maths. If you don't know maths, there's nothing I can do about it, right? When you do the course, we assume you know the maths. If you don't know the maths, you need to make sure that you get yourself up to speed on maths, okay? It's not complicated maths, but you need to know it, and if you don't know it, it's not the purpose of this course to teach you maths, essentially, right? So the same then with question 8. People say, well, if you've got 100,000 and then it goes to 200,000 in 10 years, you know, how do I know what the interest rate is? Well, in your textbook, there's the rule of 70, which rule of 70, which gives you a quick way of calculating what the interest rate would be. It's about 7%. In one of the chapters, there's a long discussion about the difference between present value and future value and how you calculate it accurately with an interest rate and a period of time, right? How do you do it? Well, you just apply that stuff. If you cannot apply it, again, there's not much I can do for you. It's just, I don't know, like standard 7 maths, right? You need to do it. If you can't do it, it's not the economics that's letting you down, it's the maths that's letting you down. Okay? Then in terms of this question, what are they saying? Well, remember, Murray and Roberts here has 100,000. They can do one of two things. They can either, and now people are getting the terminology mixed up, they can either save their 100,000 or they can invest their 100,000. You don't invest your 100,000 by putting it in the bank. You save your 100,000 by putting it in the bank. Okay? So what is their option to invest? Their option to invest means that they do some project. If they do that project, they get 7%. If they choose to put their money in the bank, what interest rate would they get on their money? Well, the interest rate they would get on their money is the same as the cost of borrowing that money, right? In other words, if the cost of borrowing was about 5%, they would be receiving 5% if they put their money in the bank. Now, they've got their 100,000. Would they rather put their 100,000 in a bank at 5%, or would they rather invest it in a project at 7%? They would rather invest it at 7%. They get a higher return, right? So if the interest rate, if the cost of borrowing was 5%, they would rather do the project, right? If the cost of borrowing was 9%, they could put their 100,000 in the bank, they could earn 9%. Would they rather earn 9% in a bank or 7% in a project? They'd rather get 9% in the bank. So when will they choose to invest if the cost of borrowing is below 5%? Okay? Are you clear on this? Do we need to spend more time on this kind of thing? I mean, the purpose of going through these questions is to identify where people have problems. Is this some problem that we need to spend more time on? How to calculate growth rates. Can we move on from that?
Yes.
Okay. You got the sentence, the natural rate of unemployment. Which of those is correct? I don't think you need to work through it too much, let's just talk through it. The natural rate of unemployment does not include those who are structurally unemployed. Is that true?
No.
No? The natural rate of unemployment does not include those who are frictionally unemployed. Is that true?
No.
It does include those who are cyclically unemployed. No. It occurs when the economy is at full employment. Yes. It occurs when there is no unemployment. No, because what unemployment is there? Structural and frictional. What unemployment is there none of? cyclical. Now you've got an aggregate expenditure curve. What's the marginal propensity to consume? It doesn't make it explicit in this question, but it's implied. I do apologize. Obviously, we just assume that the marginal propensity to import and the marginal tax rates are zero. But that is the go-to assumption. Unless we tell you otherwise, always assume that the marginal propensity to consume, that the marginal propensity to import and the marginal tax rate are zero. Okay? That's always the default unless we tell you otherwise. Go for it, you've got 2 minutes. Okay, are you happy that the answer is B? B for having a ball. No? Okay, how many people say B? Option B for ball. Okay, option A, ant. Okay. Just remember. Let's have a bit of a shot. Remember, what is the MPC? What is the multiplier? The multiplier is 1 over 1 minus MPC. In other words, 1 over MPS. So what's the MPS? 3/4. What's 1 minus 3/4? Is it the other way around?
You said MPS is MPS.
Sorry, what? Oh, is it the other way around? Sorry. Let me see. Yeah, sorry, you're right. Sorry. In other words, if the marginal propensity to save is 1/4, the marginal propensity to consume is 1 minus 1/4. Thank you. Yes. So you think that the marginal propensity to save is indeed 3/4. Okay. Shall we work through this with the numbers? Okay, so you've got an increase in investment of 100. Okay? When you've got an increase in investment of 100, what was the change in output? 400. Okay? So if you're writing your equation, you've got y equals aggregate expenditure. When you rearrange it, y equals multiplier times autonomous component. What is the multiplier? Multiplier is 1 over 1 minus MPC. In other words, 1 over MPS. That's your multiplier. Okay? So if we're taking a derivative, what was the change in y divided by the change in aggregate expenditure? It's equal to 1 over 1 minus MPC. What was the change in y? 400. What is the change in aggregate expenditure? 100. So 400 divided by 100 must equal 1 over MPS. Right? So what is the MPS? 1 over 4. What is the MPC? 1 minus 1 over 4? 3 over 4. Do I need to write it down?
Yes.
Okay, once again, I'm getting a little bit worried because I feel like these are maths problems, these are not economics problems. Okay? So you've got y is equal to 1 over MPS times autonomous components of aggregate expenditure. Okay? So autonomous expenditure. What are the components of autonomous expenditure? A plus I plus G minus B T plus X minus M, right? What do we so if this is our equation, I can write this out, and I encourage you to write it out because, like I say, I really question the quality of your maths at the moment. y is equal to 1 over MPS times A plus 1 over MPS times I plus 1 over MPS times G. I'm not going to write it out because I know the limitations of my maths, and my maths is pretty rubbish. Okay, are you happy with that at the moment? So now we want to take a partial differential, right? We want to do change in y for a change in one of these things, and that change is going to be I. You got me? You with me? In other words, change in y divided by change in I is equal to 1 over MPS. Was that too much of a jump?
Yes.
Okay, let's do it again. Work with me here. This is the last time I will do this. Y is equal to, write this out if you have a problem. If you don't know what's going on, you need to write this out. Plus 1 over MPS times I plus 1 over MPS times G minus B over MPS T plus 1 over MPS X minus 1 over MPS N. Okay? What is a change in y? A change in y, in fact, let me use the terminology of maths. Change in y, partial derivative of y is equal to 1 over MPS times the partial derivative of a plus 1 over MPS times partial derivative of I plus 1 over MPS times the partial derivative of g. And I'm really not going to write the rest out. So then what is the partial derivative of y with respect to I? 1 over MPS. In other words, the change in y given a change in I is equal to 1 over MPS, which is just the multiplier. What is the partial derivative of y with respect to g? 1 over MPS. What is the partial derivative of y with respect to a? 1 over MPS. What is the partial derivative of y with respect to t? Negative b over MPS. So, if I change government spending by 100 and I change taxes by 100, by how much would output change by? Well, the change in output for a change in government spending would be delta y over delta g, which is equal to 1 over MPS. And what is MPS? Just 1 minus b. So change in y divided by change in g is 1 over 1 minus b. Okay? So the change in y is equal to 1 over 1 minus b times change in g. Is everyone with me? Yes? So if I change government spending by 100, what is the change in y? 1 over 1 minus b times 100, because I'm changing government spending by 100. If I change taxes by 100, what is the change in y? Minus b over 1 minus b times 100. So what is the change in y if I change g and I change t by 100? It's 1 over 1 minus b times 100 plus minus b over 1 minus b times 100, which gives me 1 over 1 minus b divided by 1 over 1 minus b times 100, which is 100. So what would the change in y be? 100. No? Okay, let's do it again. I hope you're watching if you have no idea what's going on, because this is what's happening. So, okay, let's do question 11. So now you're told what the marginal propensity is. Then you get told that it changes. What's going to happen? Play with that equation. You get an answer. You happy with that then? Should we claim a consensus and call it D for dinosaur? Question 12. You are told, again, some numbers that pertain to the equation y equals c plus I plus g plus x minus m. So you're given some numbers. Then you are told that those numbers change by that amount. So then they say, if that is the case, if we knew what y was at the beginning, and those things change, what will y be at the end? Again, work with that equation, plug some numbers in, spin it around your head, and you got C. Okay, C for caterpillar. You want some time to do it, or should we move to another question? You want some time? Okay, let's take 2 minutes quickly. So there's this bank that gets 1,000 rand deposited. Required reserve ratio is 10%. Which of the following is true? Must it keep 100 of that initial in reserve? Yes. Can the banking system create an additional 19,000? No. How much is it? 9,000. The money supply contracts when the loan is repaid. Let's do 17 and 18 then. Okay, sorry. So you say your answer is? And your answer is? C. C. You happy with that? Anyone not happy with that? Raise your hand if you're not happy. Can I take it then that everyone's happy with that answer? I can move on. If you are not happy, please do raise your hand. Yeah. So how do you get what? Okay, yeah?
With the last, with C, we're getting
Yes.
8 and 6, but we're not getting.
Yeah, getting 8 and 6 but not 3.
Yeah.
Which means you're not getting the answer, unfortunately. Okay, how did you get 3 as your final? 8, 6, how did you get 3? Okay. Okay, great. So you got the nominal interest rate by taking the real interest rate and adding the inflation rate, which is 5 plus 3 is 8. Yeah?
that 8% by 25%, then gave me 2%.
Yes.
Then I subtracted that 2% from me.
Okay, hang on. So you've got 8% as your nominal, but you know that the tax rate is 25% of that. Right? In other words, 25% of that 8% is going to tax, which means my after-tax interest rate must be my 8% minus 25% of 8%. 25% of 8% is 2. 8 minus 2 is 6. Yeah?
And then the after-tax revenue rate is subtracted from inflation from the after-tax nominal interest rate, which is 6.
So you did what?
I subtracted, to get my after-tax revenue,
Yes, you took your real interest rate.
I took my after-tax nominal interest rate.
Oh, yes. And subtracted inflation. Okay, great. That's one way of doing it. Perfect. So you took 6%, right? Which was your after-tax nominal rate. Adjust that for inflation, which was 3%. 6 minus 3 is 3. Alternatively, you take your real interest rate, which was 5%, right? You know that 2% of that is going to tax. So 5% minus 2% gives you 3%. That's your real interest rate. Yeah? Okay, the government decides to increase spending and the central bank increases money supply at the same time. What is going to happen to the ISLM model?
20. What?
Option number B. Output or national income, whatever, rises and the interest rate remains constant. Yeah? You said E. National income rises, but we can't say what the effect would be on the interest rate. Yeah? I agree with that one.
Yeah.
We can't say the interest rate will be constant because we don't know what's going to happen to the interest rate. When we increase the money supply, the interest rate goes down. When we increase government spending, the interest rate goes up. So what is happening to the interest rate? Well, is it staying constant? Well, we don't know how much it's going down by. We don't know how much it's going up by. So we certainly can't say that it's constant. Yeah? Yeah? So draw two separate graphs. And one graph should IS. On another graph should LM. Right, have you drawn on one set of axes? Shift. No, it's only constant because you shifted it by the amount it made. Can't help you with that. Shifted by different amounts. What are you going to get when you shift it by different amounts? That's what I'm saying. You need to draw two separate graphs. Draw two separate graphs, then it'll be clear. That the interest rate goes down, one instance goes up in another. What's the change? You can't say. If you draw on one graph and you get confused, okay, sorry. On that point, now that I'm thinking about it, I said that these were both TUT questions, but you mentioned that we actually didn't get to this point in the TUT, did we? So we haven't gone through these yet, have we? Okay, let's just do one of them then. Because they're both testing exactly the same thing. Oh no, they're not testing the most exactly the same thing. Sorry, question 20 is the most complicated. They're not testing exactly the same thing, my bad. Okay, question 20, what's happening? The TUT questions are testing the same thing. Question 20, if you've got a steeper IS curve, what does that imply about something? And the slope of the LN curve, what does that depend on? So if you've got a steep IS curve, what does that tell you about the interest sensitivity of income? Or, shall I say, the interest elasticity of income, which is the same as saying interest elasticity of output. Or another way of saying that is the response of output to changes in interest rates. We've got a steep IS curve. What does that tell me about the sensitivity of output to interest rates? Yeah. No, it's not very sensitive. I mean, it's a steep IS curve. If I change the interest rate by a lot, how much does output change by? Very small amount. So what is it telling me about the responsiveness of output to interest rate? It's small. So the interest rate is not responsive to changes in income. Well, no, it's got nothing to do with that because it's how is output changing to interest rate. Option B, aggregate expenditure is less responsive to changes in interest rates. That sounds good. Yeah? Our spending, our output, our income is not changing much when we change interest rates. So that first one from B looks good, which means that the first one from C looks good, and the first one from D looks good, and well, the first one from E looks good as well. Okay, what about the slope of the LM curve then? Does that depend on the responsiveness of the demand for money to changes in interest rates? Yes or no? Doesn't? Slope of the LM curve. Does it depend on the interest elasticity of money demand? Yes. We derived this. Sorry? Yes. Does the slope of the LM curve depend on the responsiveness of money demanded, quantity money demanded, whatever, to interest rates? So option B, the responsiveness of the quantity of money demanded to change in interest rates. Yes. Option C, the responsiveness of the quantity of money supplied to changes in interest rates. No. Responsiveness of the interest rate to changes in the quantity of money supplied. No. Responsiveness of the quantity of money supplied. No.
Why C no?
Because it says money supplied. It's the responsiveness of the money demand curve. It's the responsiveness of the quantity of money demanded to changes in the interest rate.